In this video, we're looking at integration as a form of anti-differentiation. There are various forms of integration, and one that's commonly used is to find the area underneath a curve, and that involves definite integrals. So what we're looking at here is indefinite integrals, and it's a basic process of anti-differentiation. Let's consider the case of y equals 5x to the 7 and review the process of differentiation before we have a look at anti-differentiation. If we differentiate y equals 5x to the 7, we bring the power of 7 out to the front, so it forms a product with 5 and 7, in other words 35, and we drop the power of 7 by 1 so that the index becomes 6. So the final differentiated expression is 35x to the 6. To reverse this process, we need to change the 35 in the derivative back to 5, and we do this by dividing by 7. We also note that the index in the derivative is 6, and to increase it so it goes back to the original form, we need to add 1. So a simple way to summarize this process is to say increase the index of the power of x by 1, and then divide the coefficient by the new index, and that will take us back to the original form of 5x to the 7. One thing we need to be careful of when we anti-differentiate is to note that we can also add a constant to the end of our antiderivative. So for example, all of these options here where we've got 5x to the 7 plus 2, 5x to the 7 minus 8, they all differentiate back to 35x to the 6 because the constant we've added at the end will disappear in the differentiation process. So our solution for the antiderivative of 35x to the 6 is 5x to the 7 plus some constant. What we'll do is summarize this process in integration form. We use this symbol, which looks like an elongated S, to represent integration or anti-differentiation. And what we've seen is that we increase the power of x by 1, and we divide by that new power. So in this case, the index was originally n. If we anti-differentiate, it becomes n plus 1, and we divide by that new power, which is n plus 1. We also add a constant at the end to acknowledge that any number could be used in this process because to differentiate back, that constant will disappear. You'll also notice in the integration notation that we have the symbol dx, and that basically means that we're anti-differentiating with respect to the variable x. Let's have a look at an example of this notation using our example. So we have the integral, or antiderivative, of 35x to the 6. And the process is as follows. We increase the power of x by 1, so it becomes x to the 7. We then divide our new expression by that new power, so 35x to the 7 divided by 7. And we automatically add a constant at the end to recognize that any number could be included in this process of anti-differentiation. We can then simplify that by dividing the 35 by 7 to get 5x to the 7 plus c. And this represents our final solution for the antiderivative of 35x to the 6.